Hey, what's up, guys? This is Cheng here. So today, LeetCode number 2007. Find original array from doubled array, right? So this time, you're given like integer array original, right? And then this original array will be transformed into a doubled array, right? So basically, each element will be multiplied by 2, okay? And then they will randomly shuffle this doubled array. Okay, so now you're given like a doubled array, right? And you need to find the original array. Right? If it's a doubled array, if it can be, right, if the original array can be converted into this double array, otherwise just return empty, right? So for example, we have this this doubled array here, right? So the original array is 134 because if we multiply 2 for all of them, it's going to be 2, 6, 8, right? Which is this 2, this 3 here, right? And then here, this one is not, right? Actually, no, because 3 can be divided, can be transformed to 6, but 0, this is not right, because 0, if we divide, multiply by 2, we still got 0, right? And the last one is 1, because this one, obviously, the length of the double array has to be an even number, right? Right, because this one is odd number, that's why it's empty array, right? So the constraints are like pretty standard, right? So for this one, since everything is shuffled, we don't know which one is which one. But what can we know? At least we can get one result, which is if we find the smallest number from this doubled array, that we know the smallest number has to be the smallest number in the original array, right? Because let's say if we sort this doubled array here, right? Let's say there are like 6 numbers and it's sorted, right? If we pick any numbers right in the middle, we're not sure if that number is one of the original array or it's a result of a doubled array, right? But if we only pick the first one, and then we know, okay, so this one has to be the smallest number in the original array, right? Because double multiplied by 2 can only make this number greater or the same, because 0 is a special case. Otherwise, any number, right? Any number doubled multiplied by 2 will result to a bigger number, right? Except for 0. So that's why, if we find the first one, right, the smallest one, right, then we know, okay, that one has to be the smallest, has to be the one of smallest number, has to be the smallest number in the original array. And then with this one, if we do x plus this a, right, and then we got like this another doubled array number, right, which is 2a. And if we remove those 2 numbers from the doubled array, then the remaining ones is what? The remaining ones is the let's say we have 3 numbers, right, in this original, right? We find this one and then we remove this one from the doubled array. So the remaining 4 numbers will be the doubled for this 2. And then we can apply the same logic, right, for this one, to find this remaining. Basically, we'll try to find the smallest from this remaining 4 numbers, right? And then the smallest number in the remaining 4 double numbers will be this number, right? And then we just do this recursively, but not recursively, but I mean repeatedly, right? So that we can find all the answers, right? So when you do the implementations, you just keep in mind we need to do a small trick here. Basically, we cannot simply naively remove these numbers from this array here, because remove a number from a length of n array will be O of n time complexity, right? And with this kind of length, it will result to a O of n squared time complexity, right? So we have to do something smarter, right? So what we can do is that we can first we sort this array here, right? And then second we create a counter. So we count each number, right? And then we use a counter to check if this number has already been removed or not, and we process from the start to the end, right? So that we can make sure we're always processing the smallest number of the current remaining doubled array, right? And then in the end, we check if our result, if the answer is the length of the answer, right, is a half of this original array, right? If it is, then we know, okay, we have found the original array, right? Otherwise, just return empty. Yep. So I think that's the basic idea here. And let's start coding. So we have this length of the changed, right? We can do a sanity check here. Basically, if this length is odd numbers, right, we simply return this one, right? Because this is the corner case for this, right? And then I'll do a count, right? Counter, right? So do this one, and then we need to sort this, yeah, change sort, right? And then we process from the very beginning. We have the answer equals this, oops, and then for number, right, in changed, right? Okay. Since the 0 is a special case, right? Because otherwise we'll do something like this. Basically, if the count number uh, for the general case, and this number times 2, if they both exist, right, in this count dictionary, then we do something like this, right? So num -1, and then we count number times 2 -1, right? And then we do some answer append dot this number, right? So that's the general case, but this one doesn't include the 0 case. And why is that? Because let's say we only have 1 0, right? Because the way we're checking here is we want to make sure both of the number itself and doubled number exist in this remaining array here. But if this number is equal to 0, it then means that the number and double of it itself, they're both 0, right? And if there's only one 0 exist in this count, then this is wrong, right? Because in that case, we need at least two zeros. Because if it's not 0, then we can guarantee that number and the number times 2, there will be two different numbers. That's why this one works. So that's why for the 0 case, we need to do at least I do it this way. So I do it in the in a separate if condition here. So if number 0 and the count of number, right, is either equal greater than 2, then we can do the similar thing, right? So we can do this. And so remember, this is going to be 2, right? So here it's going to be else, right? Else if number is greater than 0, right? And this thing. So in the end, I just check this. So it returned the answer if the length of the answer is equal to the n divided by 2, right? Else this, right? Yeah, I think that's it, right? So if I run it. Okay, yep, there you go, right? So because obviously time complexity is unlog, right? Because we have a sort here. Yeah, I think that's it, right? So I think it's a little trick for this kind of double thing, double array thing. So the only key point you need to get here is that we just need to find at least one number. We need to basically fix one number from this double array, which is the smallest number after sorting, right? And then with that, once we find that numbers, we can just remove the number itself and the double of this number from this array, right? And then we can process the remaining number using the same logic, right? And then the only thing left is that when we remove it, we use a smarter way. Instead of actually removing number from the array, we just mark that number, right? Or we just do a count, right? And then we decrease the count for the number. Yeah, I think that's it for this one. And okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.